Hey everyone, hope you're all doing well. Today, we're doing something different. We're going to be rating an exam question from a real exam. This is something we do all the time as teachers, so we thought it might be interesting. If you've been watching us for a while, you know that we like to keep things brief and to the point, so feel free to pause the video at any stage. For example, if you want to try the question. Okay, here's the question. So we're going to rate this out of 10 in terms of overall difficulty. We'll solve it ourselves first, and then we'll rate it in 4 categories before giving it a final score. The categories we've come up with are creativity, how unusual and cool is it, interpretation, how much is there to read and translate to maths, strategy, how tricky are the strategies required to solve it, and maths involved, how hard is the actual mathematics in the problem. Let's get started. This is a local one from QCAA in Australia. These are all freely available, so we've put the link in the description if you want to check out the paper for yourself. The subject is called Mathematical Methods. It's not the top level maths, it's the level below. This one's from 2022 and it's the final question of paper 2, which means it's calculator allowed. Alright, not going to read through the whole thing, so like I said, feel free to pause. We've got some flying foxes. Are they on an Australian thing? I should know this. Maybe, I'm not sure. Anyway, let's talk about the key bits of information. Firstly, these are rates. That's important. So you've got the rate coming in and the rate going out in 0 to 240 minutes, which is good to know the domain. You've got the units for everything, so that's useful. 100 flying foxes initially at 7 p.m. Okay, that's good. So t equals 0 represents 7 p.m. and the 100 will definitely be used at some point, I imagine. You're after the maximum number of these things. Okay, so there's really 2 ways you can find the maximum. You can graph it if you find a function for the number of these at any time, or you can do some optimization. Since this is calculator allowed, it's probably going to just be a graph. That means you need to find a function. Since you got the rate coming in and going out, I think the strategy here is to find the net rate. So A of t take L of t. Now, since this is a rate, if you integrate this with respect to time, you'll get a function for the number of flying foxes at any time. Call it n. So the integral of this is pretty straightforward. The integral of sine is negative cos, and just need to divide by the coefficient of the t. And to integrate the constants, you just give them a t. Be careful that you're taking away the second function, so watch out for those negative signs, but at the end of the day, this will simplify to this. Now you can substitute t equals 0 and n equals 100. So c works out to be 275. Okay, so you've got the function for the number of flying foxes at any time. Now just graph it from t equals 0 to t equals 240. Here's a Desmos graph. You can see that the maximum number in this domain is 7,034 to the nearest whole number. And the time that occurs is approximately 178 minutes after 7 p.m., which is 9:58 p.m. Okay, question done. Now for the fun part, let's rate this. Okay, so keeping in mind this is for students finishing high school and it's not the highest level maths, so a lot of students would find this rather difficult. Creativity. The rate coming in and going out was pretty cool, so let's go 6 out of 10. Interpretation. You had to understand that you were given rates and think about how to find the maximum especially working it out on the graphics calculator. 7 out of 10. Strategy. A lot of students would probably get stuck on even thinking of finding the net rate. I think that's kind of the key here. So maybe 7 out of 10 as well. And the maths involved, integration is the bulk of the work. It's not super difficult. 6 out of 10. Honestly, for a final question of a paper, it's all right. So overall, let's go with 7 out of 10. Cool. That was fun. Please give us some feedback and let us know what you think of this type of content in the comments. Let us know what you think of the question as well. Do you agree with 7 out of 10? We're going to still keep doing our usual stuff, so stay tuned. If you like this, please give us a like and subscribe for more fun math content.